on the origin of optical and emission lines in star-forming galaxies. Combining the SC cloudy photoionization code with updated stellar population synthesis results, we simultaneously model the Mir Nii Ni vs. Oiv Nii, the Mir Fur Nii Ni vs. Oiv Oii, and the classical BPT diagnostic diagrams. We focus on the properties of optically classified high galaxies that lie in the normal star-forming zone in the Mir diagnostic diagram. We find that a small fraction of our models lie in this zone, but most of them correspond to the lowest explored metallicity, Z star, equal to 0.0002 at H1. This value of Z star is by far lower than the values derived for these galaxies from optical emission lines, suggesting that the far UV emission produced by post-act stars is not the source of ionization. Instead, shock models can easily reproduce this part of the Mir diagram. We suggest that it is likely that some of these galaxies have been misclassified and that in them, shocks produced by a weekend outflow could be an important source of ionization. Using a subset of our models, we derive a new demarcation line for the maximal contribution of retired galaxies in the BPT diagram. This demarcation line allows for a larger contamination from the neighboring and dominated region. Considering the importance of disentangling the different ionizing mechanisms in weak or deeply obscured systems, new observational efforts to classify galaxies both in the optical and are required to better constrain this kind of models and understand their evolutionary paths. Next article. The automated reaction pathway search reveals the energetically favorable synthesis of interstellar CH3OC3 and HQ3. Recent astronomical observations have shown that interstellar complex organic molecules exist even in cold environments, while various interstellar COMPs have conventionally been detected in the hot gas in the vicinity of high-mass and low-mass protostars. However, the formation pathway of each interstellar COM remains largely unclear. In this work, we demonstrate that an automated reaction path search based on transition state theory, which does not require predetermined pathways, is helpful for investigating the formation pathways of interstellar COMs in the gas phase. The exhaustive search within electronic ground states helps elucidate the complex chemical formation pathways of COMs at low temperatures. Here we examine the formation pathways of dimethyl ether and methyl formate, which are often detected in the cold and hot gas of star-forming regions. We have identified a barrierless and exothermic formation path of CH3OC3 by reaction between neutral species CH3OCH3H2 co-CH4CH3OC3 is the most efficient path in the large chemical network constructed by our automated reaction path search and its comparable practices. For HQ3, we obtain complex pathways initiated from reactions between neutral species HQ and CH3 generate HQ3 and its isomers without external energy. However, we also identified the competing reaction branches producing Co2CH4 and CH3Q, which would be more efficient than the formation of HQ3. Then the gas phase formation of HQ3 through reactions between neutral species would not be efficient compared to the CH3OC3 formation. Next article. Discovery of a variable multi-phase outflow in the X-ray emitting tidal destruction event Assassin 20 QC. Tidal destruction events are exotic transients that can lead to temporary super-Eddington accretion onto a supermassive black hole. Such accretion mode is naturally expected to result in powerful outflows of ionized matter. However, To date, such an outflow has only been directly detected in the X-ray band in a single TDE Assassin 14 light. This outflow has a low velocity of just a few 100 kms, although there is also evidence for a second ultra-fast phase. Here we present the detection of a low-velocity outflow in a second TDE Assassin 20 QC. The high-resolution X-ray spectrum reveals an array of narrow absorption lines, each blue-shifted by a few 100 kms, which cannot be described by a single photoionization phase. For the first time, we confirm the multiphase nature of a TDE outflow with at least two phases and two distinct velocity components. One highly ionized phase is outflowing at 910 90 80 kms, while a lower ionization component is blue shifted by 400 100 120 kns. We perform time result analysis of the X-ray spectrum and detect that, surprisingly, the mildly ionized absorber strongly varies in ionization parameter over the course of a single 60 ks observation, indicating that its distance from the black hole may be as low as 400 gravitational radii. We discuss these findings in the context of TDES and compare this newly detected outflow with that of Assassin 14 light. Next article. Deep learning for morphological identification of extended radio galaxies using weak labels. The present work discusses the use of a weakly supervised deep learning algorithm that reduces the cost of labeling pixel-level masks for complex radio galaxies with multiple components. The algorithm is trained on weak class-level labels of radio galaxies to get class activation maps. The CAMs are further refined using an interpixel relations network to get instance segmentation masks over radio galaxies and the positions of their infrared hosts. We use data from the Australian Square Kilometre Array Pathfinder telescope, specifically the evolutionary map of the Universe Pilot Survey, which covered a sky area of 270 square degrees with an RMS sensitivity of 25 to 35 μg beam. We demonstrate that weakly supervised deep learning algorithms can achieve high accuracy in predicting pixel-level information, including masks for the extended radio emission encapsulating all galaxy components and the positions of the infrared host galaxies. We evaluate the performance of our method using mean-average precision across multiple classes at a standard intersection over union threshold of 0.5. We show that the model achieves a map 50 of 67.5% and 76.8% for radio masks and infrared host positions, respectively. The network architecture can be found at the following link: https://github.com nickel1galcam. Next article. The missing quasar image in the gravitationally lensed quasar He0230 2130 implications on dark satellites and the chord lens mass distribution. The quasar He0230 2130 is lensed by two galaxies at similar redshifts into four observed images. Using modeled quasar positions from fitting the brightness of the quasar images in ground-based imaging data from the Magellan telescope, we find that lens mass models where both galaxies are each parametrized with a singular power law profile predict 5 quasar images. One of the predicted images is unobserved even though it is distinctively offset from the lensing galaxies and is bright enough to be observable. This missing image gives rise to new opportunities to study the galaxy's mass distribution. To interpret the quad configuration of this system, we test different profile assumption with the aim to obtain lens mass models that predicts correctly only 4 observed images. We test the effect of adopting chord profiles for the lensing galaxies, of external shear, and of additional profiles to represent a dark matter clump. By comparing the Bayesian evidence of different model parametrizations, we favor the model class that consists of two singular PL profiles for the lensing galaxies and a chord isothermal sphere in the region of the previously predicted fifth images. We estimate the mass of the Arnis clumps inside its Einstein radius and find that 18% are in the range 106 solar mass less than or equal to Arnis less than or equal to 109 solar mass, which is the predicted mass range of dark matter subhalos in cold dark matter simulations, or the mass of low-mass dark matter satellite galaxies. The second most likely model class, with a relative probability of 94%, is the model where the smaller lensing galaxy is described by a chord PL profile with external shear. Our study demonstrates that lensed quasar images are sensitive to dark matter structure in the gravitational lens. Next article. The spectral study of the faint radio sources in the Elate N1 field. Understanding the spectral properties of sources is crucial for the characterization of the radio source population. In this work, we have extensively studied the Elate N1 field using various low-frequency radio observations. For the first time, we present the 1250 MHz observations of the field using the accreted giant meter-wave radio telescope that reach a central off-source RMS noise of 12 UG being 1. A source catalog of 1086 sources is compiled at 5 sigma threshold to derive the normalized differential source counts at this frequency that is consistent with existing observations and simulations. We present the spectral indices derived in two ways: 2-point spectral indices and by fitting a power law. The latter yielded a median alpha equal to 0.57, 0.14, and we identified 9 ultra-steep spectrum sources using these spectral indices. Further, using a radio color diagram, we identify the 3 MHz peak spectrum sources, while 3 other MPS sources are identified from the visual inspection of the spectra, the properties of which are discussed. In our study of the classified sources in the Elate N1 field, we present the relationship between alpha and Z. We find no evidence of an inverse correlation between these two quantities and suggest that the nature of the radio spectrum remains independent of the large-scale properties of the galaxies at varying with redshifts. Next article. Effects of coupling constants on chaos of charged particles in the Einstein ligature theory. There are 2 free coupling parameters C13 and C14 in the Einstein aether metric describing a non-rotating black hole. This metric is the Reissner-Nordster OM black hole solution when 0 less than or equal to 2 C13 less than C14 less than 2, but it is not for 0 less than or equal to C14 less than 2 C13 less than 2. When the black hole is immersed in an external asymptotically uniform magnetic field, the Hamiltonian system describing the motion of charged particles around the black hole is not integral. However, the Hamiltonian allows for the construction of explicit symplectic integrators. The proposed fourth-order explicit symplectic scheme is used to investigate the dynamics of charged particles because it exhibits excellent long-term performance in conserving the Hamiltonian. No universal rule can be given to the dependence of regular and chaotic dynamics on varying 1 or 2 parameters CE13 and C14 in the 2 cases of 0 less than or equal to 2 C13 less than C14 less than 2 and 0 less than or equal to C14 less than 2 C13 less than 2. The distributions of order and chaos in the binary parameter space rely on different combinations of the other parameters and the initial conditions. Next article. ALMA survey of Orion-plagued galactic cold clumps, the warm envelope origin of hot corinos. Hot corinos are of great interest due to their richness in interstellar complex organic molecules and the consequent potential probiotic connection to solar-like planetary systems. Recent surveys have reported an increasing number of hot corino detections in Class 0I protostars. However, the relationships between their physical properties and the hot corino signatures remain elusive. In this study, our objective is to establish a general picture of the detectability of the hot corinos by identifying the origin of the hot corino signatures in the sample of young stellar objects obtained from the atomic millimeter array survey of Orion-plagued galactic cold clumps project. We apply spectral energy distribution modeling to our sample and identify the physical parameters of the modeled USOs directly, linking the detection of hot corino signatures to the envelope properties of the USOs. Imaging simulations of the methanol emission further support this scenario. We, therefore, posit that the observed COM emission originates from the warm inner envelopes of the sample USOs based on both the warm region size and the envelope density profile. The former is governed by the source luminosity and is additionally affected by the disk and cavity properties, while the latter is related to the evolutionary stages. This scenario provides a framework for detecting hot corino signatures toward luminous Class 0 USOs, with fewer detections observed toward similarly luminous Class I sources. Next article. Wisdom Project Roman 17 Beam by Beam Properties of the Molecular Gas in Early Type Galaxies. We present a study of the molecular gas of 7 early-type galaxies with high angular resolution data obtained as part of the MM-Wave Interferometric Survey of Dark Object Masses project with the atomic millimeter array. Using a fixed spatial scale approach, we study the mass surface density and velocity dispersion of the molecular gas on spatial scales ranging from 60 to 120 pc. Given the spatial resolution of our data, we characterize these properties across many thousands of individual side lines. The molecular gas along these sight lines has a large range of mass surface densities and velocity dispersions 40% higher than those of star-forming spiral galaxies. It has virial parameters alpha-vir that depend weakly on the physical scale observed, likely due to beam smearing of the bulk galactic rotation, and is generally supervirial. Comparing the internal turbulent pressure to the pressure required for dynamic equilibrium, the ratio TUR-PdE is significantly less than unity in all galaxies, indicating that the gas is not in dynamic equilibrium and is strongly compressed, in apparent contradiction to the virial parameters. This may be due to our neglect of shear and tidal forces, and/or the combination of three-dimensional and vertical diagnostics. Both alpha-vir and TURB anti-correlate with the global star formation rate of our galaxies. We therefore conclude that the molecular gas in early-type galaxies is likely abound, and that large-scale dynamics likely plays a critical role in its regulation. This contrasts to the giant molecular clouds in the disks of late-type galaxies that are much closer to dynamical equilibrium. Next article. Fluoride generative model for halo assembly histories. The mass assembly history of dark matter halos plays a crucial role in shaping the formation and evolution of galaxies. MAs are used extensively in semi-analytic and empirical models of galaxy formation, yet current analytic methods to generate them are inaccurate and unable to capture their relationship with the halo internal structure and large-scale environment. This paper introduces Flora, a machine learning framework for generating assembly histories of ensembles of dark matter halos. We trained Flora on the assembly histories from the DUREFT and VSNDPLN body simulations and demonstrate its ability to recover key properties such as the time evolution of mass and concentration. We obtained similar results for the galaxy stellar mass versus halo mass relation and its residuals when we run the Santa Cruz semi-analytic model on Flora-generated assembly histories and halo formation histories extracted from an n-body simulation. We further show that Flora also reproduces the dependence of clustering on properties other than mass, which is not captured by other analytic methods. By combining multiple networks trained on a suite of simulations with different redshift ranges and mass resolutions, we are able to construct accurate main progenitor branches with a wide dynamic mass range from z equal to 0 up to an ultra-high redshift Z20, currently far beyond that of a single n-body simulation. Flora is the first step towards a machine learning-based framework for planting full merger trees. This will enable the exploration of different galaxy formation scenarios with great computational efficiency at unprecedented accuracy. Next article. Discovery of a split stellar stream in the periphery of the Small Magellanic Cloud. I report the discovery of a stellar stream using Gaia-Dr. 3 proper motions and XP metallicities located 15 degrees north of the Small Magellanic Cloud. The stream is composed of two parallel linear components approximately 8x 0.6 degrees in size and separated by 2.5 degrees. The stars have a mean proper motion of equal to which is quite similar to the proper motion of stars on the western side of the SMC. The color magnitude diagram of the stream stars has a clear red giant branch, horizontal branch, and main sequence turnoff that is well matched by a parsec isochrone of 10 J, pH equal to 1.8 at 32 kpc and a total stellar mass of 33,000 m Sun. The stream is spread out over an area of 9.6 square degrees and has a surface brightness of 32.5 mat arcsec to the power 2. The metallicity of the stream stars from Gaia XP spectra extend over 2.5 less than mH less than 1.0 with a median of mH equal to 1.8. The tangential velocity of the stream stars is 214 km/s compared to the values of 448 km/s for the Large Magellanic Cloud and 428 km/s for the SMC. While the radial velocity of the stream is not yet known, a comparison of the space velocities using a range of assumed radial velocities shows that the stream is unlikely to be associated with the Magellanic Clouds. The tangential velocity vector is misaligned with the stream by 25 degrees, which might indicate an important gravitational influence from the nearby Magellanic Clouds. Next article. A supermassive black hole in the early universe growing in the shadows. Early JWST observations have uncovered a new, substantial population of red sources that might represent a previously overlooked phase of actively growing supermassive black holes. One of the most intriguing examples is an extremely red point-light object that was found to be triply imaged by the strong lensing galaxy cluster Abell 2744, allowing an unprecedented detailed look into this enigmatic population. Here we present deep spectroscopic JWST NIRSPEC observations of this object, Abell 2744 QSO1. The spectroscopy confirms that the three images are of the same object and that it is a highly red and broad emission line active galactic nucleus at a redshift of Z spec equal to 7.04510.0005. From the width of H beta we derive a black hole mass of MBH equal to 321,107 solar mass. We infer a very high ratio of black hole to galaxy mass of at least 3% and possibly as high as 100%, an order of magnitude or more than is seen in local galaxies. The lack of strong metal lines in the spectrum together with the high bolometric luminosity 1045 Hz suggests that we are seeing the black hole in a phase of rapid growth, accreting at 30% of the Eddington limit. Based on early JWST imaging studies, we estimate that such heavily redded, low-mass black holes can be 100 times more common than UV-selected ones at this epoch. The rapid growth and high black hole to galaxy mass ratio of a 2744 QSO1 suggests that it may represent the missing link between black hole seeds and the first luminous quasars. Next article. An ellipse of dense molecular filaments associated with high-mass protostellar systems in the Large Magellanic Cloud. Recent millimeter-submillimeter facilities have revealed the physical properties of filamentary molecular clouds in relation to high-mass star formation. A uniform survey of the nearest face-on star-forming galaxy, the Large Magellanic Cloud, complements the galactic knowledge. We present ALMA survey data with a spatial resolution of 0.1 pc in the 0.87 mm continuum and HCO emission toward 30 protostellar objects with luminosities of 104 to 105.5 Kelvin LLC. The spatial distributions of the HCO line and thermal dust emission are well correlated, indicating that the line effectively traces dense, filamentary gas with an H2 volume density of 105 cm3 and a line mass of 103 to 104 solar mass Pc1. Furthermore, we obtain an increase in the velocity line widths of filamentary clouds, which follows a power law dependence on their H2 column densities with an exponent of 0.5. This trend is consistent with observations toward filamentary clouds in nearby star-forming regions within 1 kpc from us and suggests enhanced internal turbulence within the filaments owing to surrounding gas attraction. Among the 30 sources, we find that 14 are associated with hot filamentary structures, and these complex structures predominantly appear in protostellar luminosities exceeding 504 L. The hub filament systems tend to appear in the latest stages of their natal cloud evolution, often linked to prominent HSC Roman II regions and numerous stellar clusters. Our preliminary statistics suggest that the mass of filaments accompanied by hub-type complex features may be a necessary intermediate product in forming extremely luminous high-mass stellar systems capable of ultimately dispersing the parent cloud. Next article. On the nature of the continuum reverberation of X-ray UV and optical emission of IRIS 091496206. We present the results of a continuum reverberation mapping study of the radio-quiet Seyfert 1 galaxy IRIS 09149 to 6206. The analysis was performed using X-ray, UV and optical observations made with the Swift telescope between January and December 2017. The time delays between different light curves were measured using 3 different algorithms P2CCF, Pyro and Javelin. Our results show that the time delays increase with wavelength after tau lambda 4.3, as predicted for a geometrically thin and optically thick accretion disk, but only after accounting for significant diffuse continuum emission from the broad line region. However, the measured size of the accretion disk can be up to 5 times larger than that predicted by standard theory. To our surprise, the strong increase in soft X-ray fluxes is delayed by about 15 days compared to the optical UV fluctuations, which challenges the prediction of the lamppost model. Our analysis of the X-ray variability reveals the presence of a non-variable spectral component at 0.3 to 6.0 keV along with variable excess emission at 2.0 to 3.0 keV, which could be partly related to relativistic reflection in the inner region of the accretion disk. IRIS 09149 to 6206 joins the list of objects for which the traditional lamppost model cannot explain the observed time delays. A scenario that incorporates other geometric considerations into the lamppost model, e.g., an extended corona along a scattering source, might be better suited to explain the observed long time delays. Next article. Budget equations and astrophysical nonlinear mean field dynamos. Next article. An extraordinarily massive galaxy that formed its stars at Z11. The formation of galaxies by gradual hierarchical co-assembly of baryons and cold dark matter halos is a fundamental paradigm underpinning modern astrophysics. A key test of this paradigm is via the observations of massive galaxies at early times, as the evolution of the masses and abundances of dark matter halos is straightforward to simulate, and massive halos should contain the universal cosmic baryon fraction at high redshift. Extremely massive quiescent galaxies greater than 1011 solar mass have now been observed as early as 1 to 2 billion years after the Big Bang, producing tension with theoretical models and driving significant revisions. Typical spectroscopic ages of these objects are 300 to 500 m. Here we report on the spectroscopic observations with the James Webb Space Telescope of one of these objects that is quite different from the rest, selected by it having much redder colors. We see spectral features typical of much older stellar populations, and detailed modeling shows that they formed at least 1.5 billion years earlier in time, Z11, in a rapid star formation event. Dark matter halos massive enough to host these ancestors ought not to have assembled at this time. This observation may point to a significant gap in our understanding of early stellar populations, galaxy formation, and/or the nature of dark matter. Next article. Stability and Lie-alpha emission of cold stream in the circumgalactic medium, impact of magnetic fields and thermal conduction. Cold streams of gas with temperatures around 104 K play a crucial role in the gas accretion onto high redshift galaxies. The current resolution of cosmological simulations is insufficient to fully capture the stability and Lie-alpha emission characteristics of cold stream accretion, underscoring the imperative need for conducting idealized high-resolution simulations. We investigate the impact of magnetic fields at various angles and anisotropic thermal conduction on the dynamics of radiatively cooling streams through a comprehensive suite of two-dimensional high-resolution simulations. An initially small magnetic field, oriented non-parallel to the stream, can grow significantly, providing stability against Kelvin-Helmholtz instabilities and reducing the Lie-alpha emission by a factor of less than 20 compared to the hydrodynamics case. With TC, the stream evolution can be categorized into three regimes: the diffusing stream regime, where the stream diffuses into the surrounding hot circumgalactic medium; the intermediate regime, where TC diffuses the mixing layer, resulting in enhanced stabilization and reduced emissions; the condensing stream regime, where the impact of magnetic field and TC on the stream's emission and evolution becomes negligible. Extrapolating our findings to the cosmological context suggests that cold streams with a radius of less than or equal to 1 kpc may fuel galaxies with cold, metal-enriched, magnetized gas for a longer time, leading to a broad range of Lie-alpha luminosity signatures of 1037–1040 Erds 1. Next article. A simple direct empirical observation of systematic bias of the redshift as a distance indicator. Recent puzzling observations such as the Ho tension, large-scale anisotropies, and massive disk galaxies at high redshifts have been challenging the standard cosmological model. While one possible explanation is that the standard model is incomplete, other theories are based on the contention that the redshift model as a distance indicator might be biased. While these theories can explain the recent observations, they are challenged by the absence of a direct empirical reproducible observation that the redshift model can indeed be inconsistent. Here I describe a simple experiment that shows that the spectra of galaxies depend on their rotational velocity relative to the rotational velocity of the Milky Way. Moreover, it shows that the redshift of galaxies that rotate in the same direction relative to the Milky Way is significantly different from the redshift of galaxies that rotate in the opposite direction relative to the Milky Way. Three different datasets are used independently. Each one was prepared in a different manner. All of them show similar redshift bias. A fourth dataset of galaxies from the southern galactic pole was also analyzed and shows similar results. All four datasets are publicly available. While a maximum average deltas of 0.012 observed with galaxies of relatively low redshift might not seem dramatic, the bias is consistent and can explain puzzling observations such as the Ho tension. Next article. Where can we find the merger remnant in BH-BH mergers in globular clusters? Mergers of black holes and other compact objects produce gravitational waves which carry a part of the energy, momentum, and angular momentum of the system. Due to asymmetry in the gravitational wave emission, a recoil kick velocity is imparted to the merger remnant. It has been conjectured that a significant fraction of the mergers detected so far reside in globular clusters. We explore the scenario where the merger remnant in a globular cluster is moving at a significant speed with respect to the binary that underwent merger. We study this in the situation when the kick velocity is higher than the escape velocity in the case of globular clusters, assuming a plummer density profile for the cluster. We study the evolution of the system to study the outcome, whether dynamical friction can trap the black hole within the globular cluster, whether the black hole escapes the globular cluster but ends up in the bulge, and lastly, whether the black halo becomes a halo object. We present results for an analysis based on orbital parameters of 10 globular clusters using data from Gaia-Etter 3. We find that if the kick velocity is smaller than 120 km/s, then a majority of remnant black holes end up in the bulge. Note that our results in terms of where compact objects launched from a globular cluster end up are applicable to any mechanism, e.g. a compact object ejected due to three body interactions.